Hello everyone, Mr. Mesco here, and today we're going to explain the atrioventricular blood pressure in the cardiac cycle. This is the left part of the heart. This section right here is considered the aorta. And so again, this is the left side of the heart. Now, just a quick, brief background information. Let's say this is a heart. This side is considered the left, and that's what we're looking at right now. And this side is considered the right. And that's because anatomically, if this was you, look at you. Well, this would be your right side, and this would be your left side. And so that is why this is what we're going to talk about, our left side of the heart. There you go, the T right there. So here's the aorta, here's our ventricle. We're going to say this is our left ventricle, and this is our left atrium. But we're here to talk about pressure. Well, the pressure in this area, the 5, is greater than the pressure in this area. And so blood can actually pass from this side to this side. The pressure in this area, you'll see plus, is not greater or is less than the pressure in this area, and therefore this valve remains closed. A fraction of a second later, the left ventricle builds up enough blood volume to increase its pressure. So now the pressure in this area, the left ventricle, is greater than the pressure in this area, which is the aorta. And this valve is now open because there's a greater pressure in here than there is in here. And you may be wondering, well, why is it that the pressure in here does not overcome the pressure in here and open this valve? Well, because the valves are one-way valves. So if there is pressure from here that overcomes pressure or is greater than the pressure in this area, the valve can open up like that. Open. But if the pressure, again, this would be another scenario, or like that. If the pressure in one area is greater than the pressure in this area, the valve does not open the other way around. And that's simply the way our hearts and our bodies work. It's a way to ensure that there is a one-way flow of blood, and that blood is not flowing back from where it came from, because it's like a filter. A filter travels in only one direction. You put, let's say, water on the top, it comes down the bottom, and if it were to go back, it would pick up all the salts and all the minerals that it got rid of. So this is, in a way, a way to ensure, again, one-way flow of blood. And so let's transition to an image that to look at. Wait, what is happening? Sorry. Is much more relevant to that is much more relevant. That is now appropriate. Remember, I'm still testing this program. I think on your side, nothing happened. On my side, things are looking a little funky. All right, let's get to it. If we draw another heart, let's see. Over here, we have our vena cava, and this is the vein that is bringing in what we consider deoxygenated blood. Now, hey, take a look at this, at the graph. Is there any point in which the oxygen level is 0? No. So some of these terms are used for to to make things simpler, and they're used mostly at the high school level, but you have to understand that the heart or your blood never has 0 oxygen. It's just deoxygenated because it has less blood, for example, at this level than it has at this level. And so veins are carrying deoxygenated blood And they're also carrying blood that is full or loaded with CO2. And so this is coming in this direction, filling up the atrium, the right atrium, traveling to the right ventricle. And so I would say pause the video now and and consider what the right side of the heart looks like in terms of carbon dioxide and deoxygenated blood. Which section of this graph would be considered the right side of the heart? The answer is this. This area of the graph has more CO2 and it has less oxygen. And somewhere in between here are the lungs, meaning blood goes to the lungs load up that blood with oxygen through diffusion, and then we'll take a look at this. So we could make a line right here, say these are the lungs, and then we can make another line right here and say these are cells. Cells taking up all the oxygen, and then they dump CO2, or through diffusion, they diffuse CO2 into the blood, and then that blood goes back again through the cycle to the lungs. Here, this should say pulmonary artery. Remember, arteries are always going away from the heart. I always thought artery starts with an A, away starts with an A. That's just a neat trick if you ever get confused to what arteries and veins do or in which direction they go. I hope this was helpful, and I will see you in the next video. Pachum!